Hello everyone and welcome to Robotics and Mechatronics tutorials. In these tutorials we present real and applicable knowledge of robotics, control engineering, machine learning and robot operating system. In this robot operating system or ROS tutorial we will learn how to number 1. Write a ROS Python node that will publish messages to Arduino. The Python publisher node will publish messages to a topic and Arduino will subscribe to the same topic. Number 2. We will learn how to write Arduino code that will interpret these messages, change them and publish them back to another topic. Number 3. Write a ROS Python node that will subscribe itself to a topic and that will receive the messages back from Arduino. Here is a brief demonstration of what you will learn in this video tutorial. In this terminal window, I'm running a ROS publisher node. This publisher node is written in Python. This node publishes integers that are incremented over time. The publisher publishes these integers to a certain topic. This topic is used to communicate between ROS and Arduino. On the other side, I have an Arduino microcontroller. And this is the code that's uploaded to the Arduino microcontroller. Arduino subscribes itself to the topic and receives the integers. Then it multiplies the integers by 2 and it sends back the integers. Arduino sends back the integer numbers by subscribing itself to an appropriate topic. On the other hand, I wrote a subscriber node. This subscriber node subscribes itself to the topic to which Arduino transmits the messages, and it receives these messages. And here are the integers. The integers are obviously incremented by 2. Over here, we can see published integers. For example, 883. And over here, we can see the integers that are being received back from Arduino. But before we explain how to establish this communication, let us first explain the significance of this tutorial. The significance of this tutorial is in the fact that this type of communication is often used in a control system for a mobile robot. Namely, a low-level Arduino microcontroller will control actuators or motors and receive information from sensors. The Arduino microcontroller receives commands from a higher level controller. For example, a higher level controller controlling a mobile robot determined that the center of the mass of the robot should move to the new location. It sends X and Y coordinates of the desired position of the center of the mass to Arduino. Arduino then needs to control the motors such that the robot actually moves to the desired location. At the same time, Arduino needs to send back to the higher level controller current robot position and orientation while the robot is moving. Also, before I start with explanations, I need to mention the following. All the code files developed and explained in this video tutorial are posted on a web page whose link is given in the description below this video. Also, before watching this tutorial, it is important to watch 2 other video tutorials. In the first video tutorial, I explained how to install Arduino on Ubuntu Linux machine. The second tutorial explains how to install ROS serial Arduino library that is used for establishing the link to Arduino from ROS. Links to both of these tutorials are given in the description below this video. Also, before I start, I need to mention that it took me a significant amount of time, energy and planning to create this completely free video tutorial, as well as more than 300 video tutorials that you can find on my YouTube page. And consequently, I kindly ask you to press the like and subscribe buttons. Thanks a lot. Okay, let's start. Here is a block diagram of our communication. First, we will write a Python publisher. The Python publisher is basically a Python script that will publish integers to a topic called information. On the other side, we have Arduino. Arduino will subscribe itself to that topic and it will receive the integers. Then it will multiply the integers by 2 and it will publish these integers to a new topic called info back. Finally, we will write a Python subscriber. It's basically a Python script that subscribes itself to a topic called info back, and it will print the results on the screen. The first step is to create a workspace and to create a package. To do that, we will open a terminal. Then in the terminal, we need to write a set of commands given over here. First of all, we need to create the main folder and the subfolder for our package. That is, we need to create a folder for our workspace. Then, let's go to our new folder and let's run catkin make. Perfect. Next, we need to source our environment. We do that by typing this command. Okay, next we need to create a catkin package. To do that, we need to move ourselves to our source folder, and in that folder we need to run this command. Let us briefly explain this command. Catkin create package is the command used to create packages. The name of the package is Arduino test communication, or this is the abbreviation. Then we need to include the dependencies. This package will depend on standard messages package. This package contains the standard messages such as integers, strings, and other data structures used to communicate. And then we need to include the package for ROS-PY and ROS-CPP. That is, these two packages are used to write programs, that is publisher and subscriber nodes in Python and C++. Let's execute this command. Okay, let's see the content of the folder. Over here we can see the main folder of our package. Next, we need to create the publisher and subscriber nodes. However, we need to go to the appropriate folder in which we will store our Python files. Consequently, we need to type this command. And currently, we are in the source folder. In this folder, we will store our Python files. Let's create the publisher node. For that purpose, I will type this command. That is, I will use gedit and I will specify the name of our node. Okay, here it is. Okay, let's start with coding. Every Python file should start with this line. This is a standard line. Next, we need to import ROS-PY such that we can code in Python. Since we will be sending integers, we need to import from standard messages.messages int32. Int32 is a ROS data structure for integers. Next, we need to specify the node name. In my case, I'm calling the node message publisher. And over here, I'm specifying the topic name. I'm calling the topic as information, and I will publish my data over that topic. On the other side, Arduino will subscribe to that topic. Over here, we initialize our subscriber node. We set this parameter anonymous to true to make sure that the node has a unique name. This parameter will actually add random numbers to the end of the node name. Next, over here we are saying that our node is publishing messages to this topic. That is, we specify rospy.publisher, we specify the name of the topic, the type of the message, and this parameter. This parameter simply means that we limit the number of messages that are being sent, that are being stored in a buffer, if the subscriber cannot receive the messages fast enough. Let's continue. Over here I'm specifying the frequency of communication. That is, by saying rospy.rate1, I'm saying to ROS. I want to publish the messages with a frequency of 1 Hz. That is 1 message per second. Over here, we initialize our message. Message is equal to 1. That is, we are sending integers starting from 1. And in this while loop, we are actually sending the messages. This line is not very relevant. It's simply used for debugging. This line is very important. Over here, we are publishing the messages and we are sending the int message. Initially, int message is equal to 1 and we are sending 1. Then we increment the message, right? And over here, we simply pause the code for a certain amount of time specified over here in order to make sure that the messages are sent with the desired frequency. That was our publisher node. Save the file, close the gedit and go back to the terminal. Then in the terminal we will create the subscriber node. To create the subscriber node, we will call again gedit and we will specify the name of the subscriber node. Here it is. Let's code our subscriber node. Over here we need to specify the first line, and the first line should always look like this. Then, here's our subscriber node. We import ROS.py, we import int32 data structure, we specify the name of the node is message subs, then we specify the name of the topic. I'm calling the topic infoback. You can use any other name you like. And over here we specify the callback function. The callback function is called every time the message is received. That is, every time when there is a message on this topic, this callback function will be called. Inside of this callback function, we simply print the message. Over here, we initialize our subscriber node. We specify the node name, and we set this parameter to true. Over here, we subscribe to the topic name. Keep in mind that the topic is infoback. Consequently, we are subscribing to that topic. We expect to receive integer 32 and we specify the callback function. And finally, once we do that, we simply spin ROS.py. That is, we execute the complete code on and on and on in an infinite loop. Next, we need to save our subscriber node and let's close the gedit. Let's see both nodes. They're over here. However, we cannot execute them since we don't have the executable permissions over here. To fix that, we first need to assign the proper permission to our publisher. We do that by typing chmod +x. +x means that we're specifying, that is, we're giving the permission to execute this code. And we do the same thing for our subscriber. Perfect. Awesome. We can see that both files are green now. This means that we can execute them. Next, let's explain the Arduino code. Here it is. First, we need to include the appropriate header files. These header files are the header files of the ROS serial Arduino library. We need ros.h, and since we are sending int32 data structure, we need to include its header file. Here's our node handle. Here is our message that is being sent back. Again, it's int32 message. Over here is our publisher. Similarly to Python, first we need to specify the topic name and then the message. And note over here what's being written. It's written infoback. Now, if you go back several minutes in the past, you will notice that the name of the topic that I specify in my subscriber is infoback. That is, Arduino will publish integers to this topic and my subscriber will actually subscribe to that topic in order to receive the messages. Over here is our callback function for receiving the messages from our ROS. We expect to receive integers 32, and here is the reference to our message. What happens over here? Once the message is being received, we simply multiply the integer by 2, and we assign the result to the output message.data, and we simply use the publisher to publish this message. And over here is our subscriber. This is the Arduino subscriber that will subscribe to this topic. And again, if you've watched this video 10 minutes in the past, you will notice that when I wrote the publisher node in Python, I specified the same topic. That is, the publisher node will publish messages to this topic, and Arduino will subscribe to this topic in order to receive the messages. Here's my setup function. It's self-evident. I initialize the node, I advertise my publisher, and I subscribe my subscriber. And over in the loop function that runs on and on and on, I spin my NH, and NH is the handle for the node, and I delay 1 second. And that's it. Now we are ready to run everything. The first step is to verify the code. Next, click on Tools and select your board. In my case, my board is Arduino Uno. And select the proper port. Currently, my board is on this port, and this name is very important since we will need to specify this name on the ROS side. Okay, perfect. Let's upload the code. Uploading, let's see, done uploading, no errors. Perfect. Next, let's close our original terminal. Okay, open a new terminal, and in this terminal start our ROS master. We do that by specifying, that is by typing ROS core. Whenever you want to run anything in ROS, you need to run this command in a separate terminal. Okay, next, let's open serial communication with our Arduino. To do that, we first need to set the proper permissions. That is, we need to make sure that we have the permission to write and read from this port. This name is very important, and make sure that this name is precisely the name of the port over here. That's very important. Okay, that's the case, and press enter. Enter your password, and let's continue. Finally, we are ready to open our serial communication. We do that by typing this message. That is this command. Over here, we are basically executing this file, and this is the name of the port. And let's see what will happen. Here's the baud rate, perfect, and very good sign. We get this message, setup, publisher, or info back. We can see that this piece of code is able to recognize two topics. The first topic is info back, and another topic is information. Perfect. And we can see the type of messages being transmitted through these topics. We can do an additional thing to verify our communication. Open a new terminal and type ROS topic list. This will list all the current topics. We can see these two important topics, info back and information. Perfect. Close this window, then open a new terminal window, and let's run our publisher. But before we can run the publisher, we need to source our workspace and our package. We do that by typing this command. Perfect. We run our publisher by typing this command. Let's do that. And here it is. We can see 1, 2, 3, 4, 5, 6. These messages are sent to the appropriate topic. And over here we can see the topic name. The topic name is information. Perfect. Let us now run our subscriber node. To do that, we first need to open a new terminal. In this terminal, we need to source our workspace, and we need to run our subscriber. That is, we need to execute this command. Let's do that. And here it is. Perfect. We are receiving exactly the double value that's being sent over here. For example, let's say 52, and we see here 104. Perfect. How about 58? 1116. Perfect. Okay, that's all for today. I hope that you like this video. If you like the videos I create, please press the like and subscribe buttons. Thanks a lot and have a nice day.